Now, I saw that this is probably the last lecture before the lectures dedicated to the Young Researchers Awards. And as you will see, we pass from the single structure to the large scale at urban structure and see how site conditions and vulnerability modeling, which is very much related to the performance-based design and capacity, may affect the hazard and the risk. And this is quite important because, okay, most of us are working in the design of specific structures, but there is a whole industry out there, and the administration, of course, and the civil protection, and the communities and the society who are probably more interested about the large scale, what is happening for the hazard and the risk and the losses and the fatalities at large scale. So it is interesting to investigate which is the influence and the effect of site conditions, the way that we are estimating site conditions. And also, just to find out where is my laser pointer. I cannot see. Anyway, I will show
Professor
it with.
Pitilakis, I sorry to interrupt. I don't think we're seeing your full screen, so it's not playing.
It's not full screen?
Yeah, it's not full screen. You might need to play it.
In my is full screen. Let's try to do it. Okay, now it's full screen. Sorry. And here is my laser pointer. So I will try to develop this issue, effects of site conditions and vulnerability modeling on seismic hazard and risk assessment at urban scale. I will make first a very short overview on the models that we're using. And basically, we will try to investigate these two issues using as case study my hometown at Thessaloniki, Greece. Okay, we know that site amplification is very important, but how important is a large scale? The level of detailing of site conditions is a real challenge because the problem is that we cannot perform so many studies. So we have to go to use some proxies. And as far as the VS30 is widely used as a parameter for site conditions and site amplification, so the proxies are trying somehow to estimate the distribution of VS30 at large scale, and which is really challenging and introducing a lot of uncertainties. You know the proxies, for example, based on the topographic slope or the geology, but let's see how it will be developed. The second important issue when we are working on risk assessment is the fragility and vulnerability modeling. We use often, if not exclusively, generic functions. Generic means that we are somehow estimate for different building typologies, generic models for the fragility and vulnerability modeling, using essentially single degree of freedom systems. And moreover, the single degree of freedom systems are fixed base. So you understand inevitably that when we are looking for real structures, there are important simplifications in the modeling and so important uncertainties which are introduced. In past studies, we have seen that this is probably the most important parameter, the selection of the fragility and the vulnerability models, when someone wants to go to the large-scale estimation of hazard and risk. I will not develop more this. At the end, probably I will make some more comments, but it is really the second important parameter when we are going to estimate hazard and risk at large scale. So we are going to select, let's say, two approaches, the most common ones for site characterization and site effects amplification. And then another two selection of appropriate vulnerability functions, which are now widely used, and you will see why we have selected these two. I will comment at the end about the main ingredients and parameters which are involved in the selection, and finally in the use of the vulnerability functions. For the hazard, we are using the recent European seismic hazard model, SHM20, as we will call it for so on, and the European seismic risk model, SRM20, which has been developed together with SHM20 the last couple of years. And we apply these two models and all the rest that you will see for the city of Thessaloniki. Few words about these two very updated and very good, in my opinion, models, SHM20 and SRM20. It was essentially based on a large research project, which is the continuation of past research projects in Europe, where most of the European countries and the most important laboratories and institutes are involved. You can see all of them here, so you understand the importance of this kind of endeavor and the challenges that are introduced. So the two models, this one for the hazard and this one for the risk, have seen a large, let's say, development through the last 20 years. And essentially now we are in the third European seismic hazard model, which is the most advanced, while now we are in the first European seismic risk model, SRM20, which is the first effort using this model to come up and estimate the risk at the European scale. These two models may be found in this consortium where we are all, or the most European countries and institutes are involved and are cooperating. It is called the European Facilities for Earthquake Hazard and Risk, EFER, and it is quite tightly related with the GEM. I suppose that all of us, we know the global earthquake the model, which tries to make something that we are doing in Europe for the whole world. Now, the main features of the seismic hazard model 20 of Europe, I put several points here, but the most important, in my opinion, are these which are marked with the red. So it is a uniform hazard model, fully harmonized across national borders to cover the Euro-Mediterranean region. It's the first time that the hazard is estimated without taking into consideration the national or the country boundaries. The second important issue is that it is very much closely related to the development and the revision of Eurocode. So in the new revision of Eurocode, which is under revision, ongoing now, but we will expecting to have it within 2 or 3 years from now, it is decided that the main results, the main model, and whatever we are doing in the harmonized seismic hazard model in Europe should be used as a background for the estimation of seismic actions in Eurocode 8. This is really a very important decision. And you can see, for example, the maps that have been already introduced in the annex of the ongoing revision of Eurocode. This is the S-alpha, as we say, so the spectral values at low frequencies, around 0.3 seconds, let's say in the plateau, And this is this beta, so the hazard values for the whole Europe for spectral values around 1 second. Another important issue regarding the SHM-20 is that the hazard is estimated for rock conditions, which are estimated with this value. And we are producing in the SHM-20 a lot of maps of different types with different frequencies for different return periods and for different quantiles, mean, median, and 4 quantiles for all intensity measures and types. And then we produce also the uniform hazard spectra, again with all these parameters, the 5th, the 16th, etc., for the quantiles and the periods, the mean return periods from 50 to 5,000 years. Again, it is for rock. And then, again, in the European code, we are proposing now intensity-dependent and period-dependent amplification factors, which will amplify the hazard that is estimated and given through the SHM-20 for rock sites. Regarding the SRM-20, so the risk model, based on the hazard model that we estimated before, and using other probabilistic or scenario-based analyses, we estimate the average annual losses at country level, at proportion per occupancy class, residential, industrial, and commercial, average annual losses, economic and loss of life, and proportion per occupancy class, and different other parameters and statistics. This is a typical example. On the left side, you have the map of the average annual economic loss across Europe at administration level, and to the right, the map of the average annual loss of life across Europe at administration level again. Just to see few of the statistics, you can see that the annual economic loss, the 3 top countries is Italy, Turkey, and then is Greece, followed by Romania. And the same is for the loss of life. So the main activity and the main losses are expected at the south part of Europe. Okay, with this introduction of the models that we're using, we go directly to the study area. The study area is my hometown in Thessaloniki, which is, in my opinion, one of the best documented cities in terms of local site conditions, the knowledge of local site conditions, the exposure, and the vulnerability. It is a city of about 1 million inhabitants, and the area is about, as you see, 126 square kilometers. The buildings that we are going to work with are about 80,000, based on the census of 2011, not the very last one. So we are using, as said, 2 approaches for the side effects and 2 approaches for the vulnerability curves that we are going to use. The first approach is essentially based on the ground motion prediction equations, the models that we are using, but with the VS30 values, which are estimated with a rather good approach based on the macrozonation study that we have for Thessaloniki. The background colors here are the 3-4 soil types according to Eurocode 8. We are using OpenQuake engine, and whatever you will see later on is for 475 years return period. It is considered quite rigorous, but also quite demanding. But it is something that we are often use ground motion prediction equations, supposing that we know quite well the distribution of the VS30 in large scale. The second approach is a little bit more simple. We are using the VS30 that we estimated from the SHM-20, which is not varying very much in the whole municipality and the other municipalities of Thessaloniki in all this. But knowing very well the site conditions from the macroresonation study, and not only, we apply directly to the values of the hazard estimated for the whole city of Thessaloniki, the amplification factors, site amplification factors, which are estimated using the latest methodology, which has been presented in the last World Conference by myself and my colleagues. So it is considered a little bit more simplified as is using amplification factors and not spatial variability of the hazard and site conditions as it is used in the previous one. Just a quick look on a glance, let's say, on the new site classification. There are some differences with the existing one in Eurocode. The most important probably is the introduction of the fundamental period, because we believe that this is one of the parameters that should not be out of any future estimation of site conditions for code provisions. And so, as we know very well from the data that we have, the soil profile down to the rock, from more than 600 sites all over the world, we can estimate quite accurately the site conditions, and these are reflected in this table. And then we estimated with different methodologies that are presented in the previous paper that I saw in the last World Conference in Japan, the amplification factors which are intensity dependent. This is strong earthquakes, let's say a PGA around 0.5. This is less than 0.1 G. And so you can see for the FS, which is for the low frequencies, and for the 1 second, and we can see the evolution of the, and the decrease, if you want, of the site amplification factors. Okay, now, this is the second approach, and you can see the variation of the S alpha, and let's say for the 1 second, this is the case, and for the PGA, which is more or less the spectral values at low frequencies divided by 2.5, as is suggested in the Eurocode. But let's go to the more detail now. Approach 1 for site estimates and approach 2. You can see the PGAs in both cases, and you remark immediately that there are some differences. The question is how these differences will be reflected to the risk estimation that we will see later on. And this is, again, for the, it is for the 1 second. Again, we see some differences, essentially in the shoreline, along the shoreline of the city. Now we go to the second ingredient of the whole modeling, which is the exposure, which is used then for the vulnerability classes and for the vulnerability curves that we are going to use. In this case, now we have selected 2 models. The classical model, which is used in SRM-20 in Europe, which is more or less the same as in GEM. You can see the exposure, and you can see in three estimations here, let's say, how is the distribution of the typology of the buildings that we have in Thessaloniki. The large majority, as you can see here, regarding the construction type, it is infilled frames and moment-resistant frames. We have very few masonry buildings. The second here regards the level of seismic design and construction, with low seismic to high seismic and non-seismic. Non-seismic means that we have about 13% of the structures in Thessaloniki which have been built before 1952, where the first seismic code has been applied. So you can see that most of the buildings are for low, meaning that it is structures built around 70 or 80, but little by little we increase the percentage of the buildings with the high code, which is the most recent one after 2003. And here we have the height of the buildings, 1 story up to 6 stories or more. The second model is more dedicated to the classification and the typology of the buildings that we have in Thessaloniki and in Greece in general. It is a proposal by my friend and my colleague, Andreas Kapos, about 15 years ago. And here, with the same applies the classification and the percentage, with the exception of this one, of course, are a little bit different. Based on this, we are going to see what will be the influence and the impact to the risk. The main difference between the two models is that the first one is derived exclusively from simplified equivalent single degree of freedom oscillators. It is exclusively made for large-scale applications. It uses as intensity measures the PGA or the spectral values at 0.3 seconds, 0.6 seconds, and 1 second. And this is depending on the building typology. We will see that this intensity measure will be used because it is the most often observed in Thessaloniki. And it proposes 4 damage states. The Kapos model is based on an hybrid approach using mostly analysis of simplified 2 degree of systems of typical buildings, plus some empirical data. The intensity measure that is used in this case is only the PGA, not this one. And he is proposing 5 damage states. In Thessaloniki, for the first model, you can see that probably we can use, in our case, only the spectral values and at 1 second as intensity measure. What is important here is to see the difference between the models. Of course, they are not comparable directly because in the first approach, in the first model, we are using spectral values at 1 second, while in the Kapos approach, we are using the PGA. But if you go to the vulnerability curves, you will see that it seems, even from this rough approach, that probably we should expect higher vulnerabilities and losses using the Kapos model. I will comment on this later on in more detail. In order to compare the two, but the aim is not to compare the two models, is to prove and to highlight what could happen if we are going to apply one model or the other. So here we somehow try to make the correspondence between the two models. and I believe that it is very reasonable. And let's go directly to the physical damages. And this aggregates the damage distribution along the whole city. You have here the fragility model based on the most recent SRM20 model that we're using, and GEM. And the second model is by Kapos. So we have two models. And in each model, we have the two side effects models, the type 1 and type 2, as you know. From the first glance, we can say that if we stick to both, let's say, fragility models, we cannot see big differences when considering the side effects at large scale. You can see here more or less the same, not big difference, even in the complete and extensive damages cases. And the same is for the other fragility model. Again, the differences are not so important. So one could conclude out of this that at large scale, at city scale, the detailing of the site conditions is probably not so important. But if we go now to the losses and the estimation of the losses, the two models have significantly high differences. In particular in this part, which is the most important, let's say, and the most costly and affecting the population and the fatalities. We can see out from just comparing these colors here and these colors here that the second model for the fragility is much, much more conservative. It proposes 2 or 3 times higher losses. So what is the first lesson out of this? That probably at urban scale, the most important parameter is the selection of the fragility and the vulnerability functions and not the side effects and not the site conditions or the modeling and the detailing of the site conditions. If we go now a little bit more to the district level, we can see that there are some difference for the site effects, for the site conditions, in particular in this, let's say, more soft type soils compared to the two approaches. This means that the way that we estimate the spectral values and the intensity measures may have an important influence rather in local scale and not in global scale. When we apply, of course, the model which is set as SRM20, which is not very detailed. I remind you, it was the single degree of freedom systems, etc., and fixed base. While in the second case, this model could be estimated as more adapted to the conditions of Thessaloniki, but here the site conditions play no role at all. If we go in more detail, not in the municipalities, but in the administration districts, then we can see again that probably now the site conditions are playing a more important role. And you can see that the percentage of the buildings with complete damage is more pronounced. Again, in the case where we have seen previously that it was not so important. Of course, in the second case, these differences and this impact is amplified. Let's go now to the economic losses. It is very interesting to see that if we stick to one model with the two side detailing approaches, the differences are really very few, around 4 billion euros for the 475 years earthquake scenario. And the aggregate loss ratio is rather reasonable. when we are going to use the second model for the fragility, and I remind you that behind these approaches, the performance-based design and the capacity is implicitly introduced in the models, just to stick with the main title of the conference. Here, the aggregate economic losses are doubled. So we must be careful when we're using one model or the other, while in large scale, probably the site conditions could be expected not so important for large scale. And again, if we go to the economic losses and focus in the district and the administration district, etc., we can see some differences which are important and where the site conditions may play a more important role now, as you can see here, for example, where we have in this shore area with very expensive buildings that the expected loss ratio is increased. So the site conditions and probably the geographic distribution based on how expensive are the structures may introduce the site detailing in a more let's say important way. And I'm concluding with some general lessons that we learned out of this. First of all, there are pretty much uncertainties involved in all the methodological chain of the seismic risk assessment. And we all know this. The problem is how we can reduce it. When we are considering large-scale approaches for the hazard and the risk, insurances, administration, civil protection, etc., probably we can go to acceptable estimates of the risk using a proxies of the site modeling. But when we are going to see in detail in local scale, then site modeling play an important role. On the other hand, which is probably the most important, is the selection of the fragility and the vulnerability models. This may double the risk or triple the risk. And this happens both in small and in large scale. I repeat again that the comparison between the two vulnerability models have not been made to prove one that is better from the other. No, it was just to show what is the impact of the selection of one or the other. The dispersions are very high. And I remind you also, as I promised to say at the beginning, that all the generic fragility curves that we're using so far are neglecting two very important parameters. The first is site amplification plus soil structure interaction, because they are all supposed to be fixed base structures, single degree of freedoms, again. And the second, we also neglect the aging of the structures. We are using, in most cases, for the single degree of freedom systems, the as-built geometry and parameters of the structures, while we are estimating the risk after 50, 60, 100 years. And the modifications and the aging effects from the corrosion and other parameters that the structures may have suffered may be very important. So these are the two most important things that for the moment are neglected. And again, as I promised, the main question that probably many of you may have is, okay, you said that the single degree of freedom system for the estimation of the fragility and the vulnerability may not be so accurate. Is it so? My answer is yes, it is so. When we compare full 3D estimates with extremely well knowledge of the geometry and the typology and all other characteristics of the buildings, and we perform incremental dynamic analysis, and we have made the health monitoring of the structure to see the aging effects, the soil structural effects as well, we see notable differences between the generic and the real fragility curves. And to be a little bit more provocative, I would say that in most of our cases that we have studied, the real fragility curves are higher than the generic one. So with this, I'm closing my lecture, hoping that I open some questions for future research, and we need future research on this important subject. Thank you very much for your attention.
Dear Kyriazis, thank you very much also for keeping up with the time. And it was a very interesting presentation. Are there any questions from the participants? It seems the lecture was so perfect, you left nothing to be questioned.
Thank you.
Many thanks, Kyriazis. It was a very interesting lecture, and I congratulate you for all the work you have done in regard to the European projects. And I hope you keep on doing what you have been doing in the last many years.
Thank you very much. Let's keep ourselves healthy, and we will continue.
Healthy and wealthy.
Exactly.
Okay, ladies and gentlemen, we are leaving you now. Bye-bye.
Thank you.